Alright, so this is going to be a video about integration by parts, which is going to be another integration technique that we're going to be utilizing in this class. If you haven't already, make sure you watch the video before this one. It's on integration by substitution because you're going to need to understand that to apply it to this, because sometimes you have to use both of those integration techniques. So let's break down what integration by parts is first, kind of get an understanding of it, and the way to really understand this is by working out a couple examples. So that's what this video is going to be primarily doing, is working out two examples so you can actually see integration by parts in action. All right, first thing you have to understand and memorize for integration by parts is this equation right here. The antiderivative of u dv is equal to uv minus this, the integral of, it almost looks like it says voodoo. Okay, v du. That's lots to break down. We're not actually going to, this video is not going to actually show the proof of where that came from, but it actually just comes from product rule. If you kind of reconfigure product rule, you end up getting this equation right here. There's tons of videos online, so if you want to look that up yourself, if you want to look in the textbook, you can do that as well. But just for the sake of time, I'm not going to be explaining in this video. It's also not part of the class where you have to be like, where does this equation come from? You do not need to know where this equation comes from. Just make sure you understand how to use it. And that's what I'm going to be showing in this video. So make sure you memorize that. And then next we have this LIATE rule. LIATE's obviously not really a word, but we're going to use this as a mnemonic device to remember the rule for figuring out what that u is. So we have a u, the antiderivative with this u right here and this dv. What the LIATE rule is going to help you figure out is what should your u be. And generally this works. There are exceptions to the rule, obviously, like any rule. The LIATE rule works for primarily most of these problems that we're going to be doing in class. So that's what we're going to be focusing on, is using this. The LIATE rule for integration by parts tells you the order that you should pick your u in. So if there's a logarithmic part of the integral, then you're going to want to use that as your u. If there's not, then you just keep going down. Is there an inverse trig, like arc cosine, arc sine, arc tangent, that sort of thing? That would be the next thing to do if there was no log. If there's no inverse trig or log part of that integration expression, then go to algebraic. If there's no algebraic, or the ones above it, then trigonometric, and then eventually exponential. So it's basically figuring out what your u should be. So this helps you figure out what is your u. So I'm going to write u equals question mark. You're going to follow this LIATE rule to figure out your u. So we're going to actually be using this rule through the two example problems that we're going to be doing. All right, so to really kind of make sense of this and use that equation, let's look at this example problem we have right here, where we have the integral of x times secant squared x dx. And the main thing that you have to understand first when you're looking at this is you have to realize that you cannot actually use u substitution on this. So that last video that I made that you should have watched, you cannot do integration by substitution with this because there is no value that you can substitute your u in to substitute for. If you don't believe me, then actually try to work it out, but it just ends up not working. The x's turn into a bunch of u's, and then it just ends up with the exact same problem that you already had. So you're not going to want to do it that way. In this case, you're going to want to recognize that there is some function times another function, so integration by parts is probably the best bet for this, and it is, actually. First thing we're going to do is use this LIATE rule. So first step is figure out what your u is right here, and then the other part's going to be dv. In this case, our u, based on the LIATE rule, is going to be algebraic. There is no logarithmic, and there's no inverse trig on this, so we're going to go with algebraic here. In this case, the algebraic part of that expression would be x. So in this case, the LIATE rule tells us that our u, in this case, should be x. The rest of the formula, we're going to be figuring out all of this other stuff. So like right here, this du, we're going to figure that out next. To figure that out, it's going to be similar to the u substitution that we did in the last video. By doing the derivative of u, now that du comes out. So we need the du as part of this formula. Well, there it is. And to figure this out, the derivative of u, which is the derivative of x, in this case is just going to be 1. Now we just want the du, so what I'm going to do is multiply both sides by dx, and you end up with du is equal to dx. So we have this part of the formula and this part of the formula taken care of, as well as this part right here. So we're in good shape. Now we got to figure out the v and the dv, because we have a dv here and we have a v here. Okay, so we need to figure out that as well as the v over here. So let's do the next part here. We're going to figure out what our dv is. So the main part of this formula, it starts like this. There's some function times some other function. In this case, this is going to be our u. So this part right here has to be our dv. So that's actually what we're going to do, is we're going to set our dv equal to secant squared x. Now it does say that this is the part of the formula. This is where it starts. Okay, this is the start of the formula. That's the using the formula. So make sure you start with dv as your next option here. So I'm going to write dv, in this case, is going to be equal to secant squared x dx. So I'm going to kind of highlight this really quick just so you can kind of keep track of everything. And then our u, in this case, is our x. So everything is substituted for with those same colors. From here, we need to figure out what our v is. Well, we have the dv right here, so all we have to do is really just the antiderivative of this dv, and the antiderivative of secant squared x is just going to be tan x. So I'm going to write that in right there. Now this does follow logic. If you do the derivative of v, you do get secant squared. So dv over dx would be equal to secant squared x, which is what we have there. So now we have everything we need to use that integration by parts formula right over here. Okay, so let's do that. So we're going to have uv is the first thing. So that's just going to be x times tan of x. So that's the uv part of it. So that's this part right here. All right, minus the integral of v, which in this case is tan x, times du. Okay, well, du is equal to dx. It says it right here. So we're just going to put a little dx right here. And we're getting closer to breaking down this problem. It's not completely done because we still have that integral. Well, lucky for us, the last video, you should have watched it, we actually go over the antiderivative of tangent of x. So if you do not understand how to find the derivative of tangent of x, make sure you watch that other video. I'm not going to waste the time on this video doing that and just repeating myself, but you're going to want to look back at using integration by substitution to figure out the antiderivative of that tan x. All right. Now, I already know it because of the last video, so I'm just going to write it in there. It's minus negative ln of cosine of x with the absolute values, the absolute value bars there, and then we have a plus c on the end of it there. Okay. Obviously, we want to simplify this. The minus minus can be simplified to a positive right here. So overall, you can write the answer as x tan x plus ln of cosine of x plus c. And that's the final answer for this problem. Okay, things I want you to notice while we did this problem is all the color changes. Make sure you understand why I changed colors, because every single color change is a separate thought. So you want to understand the why with all my thoughts, because you have to follow this same procedure. If you do not follow that LIATE rule and say I did secant squared x as my u, you would hit a dead end, and that's kind of a sign that, oh, maybe I need to go back and switch my u up because what I picked is not working. So make sure you keep that in the back of your mind. If you ever reach a dead end and you don't understand what to do, chances are you picked the wrong u. All right, let's do another problem here. We have x times ln of x. We're doing the integral of that expression right there. And the first step, just like before, is we got to pick our u. Now, just to kind of reiterate, we want to use that LIATE rule for picking our u. So in this case, we have x and ln of x. Well, the top one is logarithmic, and we have that ln of x. So our u in this case is not going to be x like the last one. This time, it's going to be ln of x. So it's kind of switching it up a little bit, which is good. So you can kind of see how these different problems work. Okay, now we need that du. So what we're going to do is do the derivative of this u to get a du. Du over dx is the derivative of the u right there, which, if you remember, the derivative of ln of x is 1 over x. Okay. We're going to multiply dx on both sides, so then we can solve for that du, which we need for this problem. It is important to note that some people skip right to this step right here and don't even bother writing the derivative there because you're just multiplying the dx over. If you're doing these problems a bunch and you're practicing and you can see that you can do that shortcut, by all means do it. This is a teachable video, so I'm actually going to run through every little step, but just make sure you understand that you don't actually have to do that. If you want to jump right to that bottom step where I multiply the dx over, you're not going to lose any points. I get what you did there. So anyway, let's keep going. That's our u. The next thing we have to do is figure out that dv. The dv is whatever's left. In this case, it's going to be x dx. Okay, so our dv in this case is going to be equal to x dx. Now our v is the antiderivative of that dv. If you did the integral of both sides, you'd be solving for v. I'm not going to put a plus c in this. If you notice in the last problem, I did not put a plus c as well because it just all comes out at the end anyway. Anyway, the antiderivative of x is going to be x squared over 2 plus c, but we're not going to put the plus c in there. Okay. Now we can use that integration by parts formula again because we have every single part that we need. We figured out the u and the dv, and now we just have to multiply u times v, and then we have to do the integral of v times du and subtract that. So that's what we're going to do here. So we're going to do uv. In this case, it's going to be x squared over 2. I'm doing the v first, just I don't know, convention. Usually they put the algorithmic part first. Doesn't matter the order though, but I just did v times u, which is the same as u times v. And then I'm going to subtract the integral of v times du, which is 1 over x dx. Okay. Now what's nice about this is it simplifies pretty well. So like x squared over x, this cancels here with this, and you just have x over 2 here. What I'm going to do to kind of make my life a little bit easier is I'm going to parse this out. So I'm only going to solve that x over 2 dx problem over here. So I'm going to just write this real quick in here, x over 2 dx. I'm going to do that, and then I'm just going to transfer it back to that underneath that yellow there. All right. Well, the antiderivative of this, I'm going to pull the 1/2 out just to make it a little bit easier to look at. You don't have to do this if you don't want. The antiderivative, we're going to use reverse power rule on this. So we're going to add 1 to that power. So it's x to the first power. So we're going to add 1 to it to make it second. And then we divide by whatever that new power is. And then we're going to do a plus c on this. Okay. Then we're going to transfer that up underneath the yellow. I have to rewrite this part. So don't forget that other part because you need the entire formula for integration by parts. Minus, and then we're going to be minusing that purple there. I'm going to simplify it. X squared over 4 plus c. And that is the answer for this problem. Again, lots of color change. Try to follow the rainbow. Make sure you understand the why for every color change for all of these problems. All the problems I do in all of these videos, make sure you really understand those color changes. Super important. If not, make sure you drop me an email or a comment or anything so I can answer your questions so you understand what's going on with this process. It's very procedural, step by step. You want to find the u using the LIATE method. Find every single other part of that integration by parts equation, which means find the du, find the v, find the dv. You want to find it in that order. So once you find the u, find the du. Once you find the du, find the dv, which is just the rest of the problem. And then once you find the dv, do the antiderivative to find v, and then just fill in the entire formula. So that's integration by parts. If you have any questions about anything in this video, let me know.